distinction between double glazed windows and double skin facades from heat transfer point of view. As you know, the envelope is the part of the building which interacts with the exterior factors as a first barrier. It represents the most important factor in determining the level of comfort, natural lighting, and ventilation ability, and finally how much energy is needed for heating and air conditioning. The main purpose of this study is to identify and emphasize the difference between single skin facades and double skin facades from heat transfer point of view. For this purpose, we're taking into account the total heat transfer resistances, transmittances, and heat fluxes. Designing a double skin facade, it is complex. The system itself is a complex one, which depends on different factors. If you have, for example, natural ventilation, mechanical ventilation, hybrid ventilation, it depends on the building's orientation, it depends on how the building is constructed, it depends on the region where the building is placed. So, in double skin facades, the heat transfer involves several phenomena which occur simultaneously and which overlap. A schematic heat transfer model, so to say, is presented in those pictures where you can see in A figure heat transfer into a single glazed window, and in the other B and C heat transfer through a double skin facades without shading device inside the cavity and with a shading device inside the cavity. We started our calculation from a double glazed window, which was considered 2 meters tall, and to simplify the method, we considered the heat transfer during the night. The effect of solar radiation can be ignored. This way, it was considered the stationary regime in one direction, and the effect of the casement is ignored. The heat transfer indicators, usually such as global heat transfer coefficient and thermal resistance, are usually calculated for when we design a building in steady state regime. In most of the standards, that's why we choose this way of calculation. As we all know, the total heat flow is the difference of temperature between inside and outside divided by the total heat transfer resistance. The heat transfer resistance, as in this equation you can see, is composed of different factors, which consist of the convection and radiation inside, the conduction between the glass sheets, the convection and the radiation between the sheets of glass, the conduction again in the exterior glass, and convection and radiation outside the system. Of course, the difficult part when calculating heat transfer indicators is the convection inside those cavities. So, for the case of double glazed window, the convection coefficient was calculated using this relation, where Nusselt depends on aspect ratio and the Rayleigh number. The Ka was calculated on the medium mean temperature between the glass sheets. Now, if we extend this way of calculation to the double skin facades, we add another sheet of glass, and we add also a larger cavity, this time, which can vary from 25 centimeters to 2 meters, and the exterior glass is usually a secure glass, which can go from 8 to 12 millimeters. The double skin facades configuration could be like this, where those from the right are the double glazed window as an interior envelope, and the other one from the left is the secure glass of the double skin facades. And the larger space between them is the double skin facade cavity. So to extend the method, we need to add another factors, such as the convection inside the air cavity of the double skin facade, and also the conduction through the secure glass, which is the exterior envelope in this case. The calculation method is an iterative one, and again the difficult part is to determine how to estimate the value of the convective inside the cavity. So if we look again at the total heat transfer resistance, we can see that for double skin facade we add another two components: the convection inside the cavity and the conduction through the secure glass. As a conclusion, we can say that the difficult part for those kind of calculations are to estimate the convection through inside those two cavities. The coefficient varies depending on the type of the envelope chosen for the interior and the double skin, and for the cavity it depends on ventilation mode, which can be natural, mechanical, or hybrid. As indicated in literature, the energy performance of a double skin facade depends on various aspects, as location, orientation, climatic condition, type of inner and outer envelope, thermophysical properties of materials included, type of double skin facade, and so on. Specification for such system. I wish you all a successful Congress and a pleasant stay in Belgrade. For more details about this paper and result regarding this paper, an article will be published in Energy and Buildings with all kind of details and results for this paper. Thank you all, and I wish you success.